All right, welcome to our next video in the series. This is Programming in Java. We are in our Objects and Classes unit. You should have seen the previous videos in this sequence to be able to understand this. You need to have an understanding of how inheritance works. We're going to talk about a big idea right now. It's called polymorphism. Polymorphism is one of the pillars of object-oriented programming. One of my students nicknamed it the ape of OOP. And the APE stands for Abstraction, Polymorphism, and Encapsulation. Abstraction is the distance between using a tool and understanding a tool, whether it's a tool acquired from another library, right? The substring method in string. I don't know the individual statements on how it works. I trust that it works, and so I use it. The functionality of substring has been abstracted from me. If I define a complex method that's a couple hundred lines of code, as long as I built it well, then I can just refer to all of that complexity with a single statement, right? Call that method. And now all of the complex details have been abstracted. So that's abstraction. Encapsulation is where we decide to make some fields in a helper class private. We do this to protect them, to make sure that we, the developers, the coders, don't accidentally assign some invalid state to our codes, or we don't want to have a negative age. We don't want to have, hopefully, a negative bank account, something like that. Perhaps we don't want a denominator and a fraction to be 0. So we make the fields private and we force ourselves to use public setters and getters to access those. That's encapsulation. Polymorphism is the big new idea, and it says that I'm allowed to treat different objects in the same way and get different results. And what I mean by that is what I'm trying to demonstrate here with this particular class hierarchy. So I have animals at the top of my hierarchy. We've got dog, which extends animal. And then I forgot a little bit for my cat class right here, which is another helper class. It's also going to be a child. We're going to say extends animal. So dog and animal are siblings. They don't have any relationship to each other. If a dog had a method called bark, cat wouldn't be able to do that. If a cat had a method called pout and be whiny, a dog couldn't do that. But they both inherit from animal. Now what we're seeing here is that in animal, I defined a method called speak. And I used method overriding to replace the speak in dog and to replace the speak in cat. So what happens is if I make some objects, so we'll say animal A equals new animal, and dog B equals new dog, and cat C equals new cat. Well, I should be able to ask all of these things to speak, and they would all speak in their own way. What's interesting is, they're all being told to do the same method, but the result is going to be different, right? We're going to ask animal to speak, then dog, then cat. The result we're going to get, because I did a.speak for all of them, it should be a.speak, c.speak, a, b, and c.speak, not just a the whole time. And now, voila. Animals, because they're generic, we don't even really know what they are. They produce question marks, because how does a generic animal speak? I don't even know what it would say. A dog says woof and a cat says meow. This is polymorphism right here. So the idea that you're allowed to treat different objects similarly, I think it's traditionally looked at in an inheritance hierarchy, right? All of these things are animals, but some of them were told to do this particular behavior differently. Another great example of this is I might say, animal winner equals, and I'm going to make a method called contest. Let's say two animals have to compete to see who the best animal is. And I'm going to put the dog in there, and I'm going to put the cat in there. Now, I haven't defined this yet, so I'm going to make this contest method. I'm going to go ahead and define it in the animal class. So we're going to say public animal contest, and I'm going to take two animals here as a part of this method, animal A1 and animal A2, right? And there, maybe it's a beauty contest or they're in Thunderdome. I don't know what's going on. But we're going to figure out whichever one of these is the better, we will return that. And let's say we're going to do it with a coin flip. I think the easiest way to simulate a coin flip is to say, all right, if math.random is greater than 0.5, remembering that math.random produces between 0 and 1 as a decimal number inclusive. All right, if we get heads, essentially, I'll return animal 1. If it's not, I'll go ahead and return animal 2. And so now, the way that it looks, contest, did I do this right? BC. This method is undefined for the type inheritance demo. Are we sure? Oh, because I have to call it duh. Yes, I just broke my brain there for a second. All right, let's do it this way. Not even close. Good try. I'm going to make one parameter. So I'm going to say animal A1. And in fact, I'm going to call it animal other. And what we're going to do is we're going to say, all right, so one animal object is going to call this. If the number ends up being bigger than 0.5, we're going to return this animal itself, whoever called it. Which, by the way, in our earlier conversations, we talked about how to use this to refer to a field. We can use this to refer to particular methods. If I want to refer to myself, then I can do that with this, and that's a good example of it. If I didn't win, then we'll assume it's the other guy, the other animal that wins, and we'll say other. So the correct way to do this is we would have said the dog challenges the cat in a contest. Okay. And then what I'm going to do right here is I'm going to ask the winner to speak. And what's cool is a little bit of the Schrodinger's cat, right? We don't know who's won right here. In any given execution, because the outcome of contest is random, then winner could be a dog, it could be a cat, and we don't know. But thanks to inheritance, thanks to polymorphism, I can assign, it'll either randomly be B or C to this one winner spot, that I can ask the winner to speak. So I'm going to go ahead and comment out these other speakings right here, just so we can see what's going on. And this time it says woof. I execute again, woof, woof, meow. There it is. All right. So we ended up flipping dog 3 times before we flipped cat once. So this is what polymorphism is, right? I'm able to do a little bit of subclass parking right here. It's either a dog or cat. It's parked in an animal spot. But because I have defined this method in animal, in dog, in cat, and whatever arrives here will know how to resolve how to speak, then I can, by polymorphism, produce an output. And this is really powerful and useful. Imagine you were making a video game, you have lots of monsters. You want to be able to ask all your monsters to attack. I don't want to have to rename that action for every monster, but because they can all define their own attack action, maybe each of your monsters inherits from a superclass called monster, right? And then overrides whatever the generic monster attack is. You can get this rich, diverse behavior with all of your subclasses doing different things, but your code will look very clean, right? B has a contest with C. The winner goes there. We ask the winner to speak. It's meant to be a bit of a time saver. All right, so that's the first part of the presentation. The second thing I want to put out is, let's say, I married a wonderful, beautiful veterinarian, and we like always have a lot of pets. So what if I wanted to do an array called my house, which I think at any given time there are probably, 4 slots for animals in my house would be my guess. Another advantage of inheritance is I can, just as though I were subclass parking a dog in an animal spot or a cat in an animal spot, I can make an array that holds animals. And now not only can this hold generic animals, like let's say I just made a new animal right here, hooray, that's in my house location index 0, but I could go ahead and do in index 1, I could make a new dog, my house index 2, I could make a new cat. And my house index 3, I'm going to go ahead and leave empty right now. There's always room for one more, right? We're going to leave an empty spot for an animal in our house, okay? So what I'm going to do now is I'm going to go through every animal in my house and I'm going to ask it to speak, right? So I'm going to make a for each loop, right? For each loops are great for this. I'm going to say, hey, pull all the animals out of my house. You can just call it animal A. Did I define A yet? Oh, I did. Animal Annie, a little Star Wars reference right there. And go and pull all the animals out of my house. And then when you get to these animals, just ask them all to speak. And because of polymorphism, right, I parked the animal in a spot for an animal, a dog in a spot for an animal, a cat in a spot for an animal, then I left that last spot open. Let's watch what happens. So, and I've shut off all the other printing methods right now. We run this code. The animal talks, the dog speaks, the cat speaks, and then we get this exception. And you probably could have guessed it's a null pointer exception. My little for each loop arrived at the last index and it said, hey, animal who is there, I need you to speak. And Java says, actually, there's nothing at this location right now. It's null. We go to speak and we get an exception. If I wanted to protect this, I could have done something like if Annie is not null, then go ahead and speak. Let's see if this actually does what I want it to do. All right, we'll try and run the code again. Animal woof meow. Go through my house as long as it's not an open spot. Go ahead and ask it to perform. All right, so in summary, polymorphism is the act of asking different things to do a similar behavior. You get a different result, usually in reference to an inheritance hierarchy. And that is powerful because that affords us a bunch of flexibility. Okay, thanks for watching.